Algebra 1, Day 6. Today we're going to be reviewing the entire unit. So we're going to be taking a test over the material, a very, very short test that's super easy and super simple. And I want you guys to get a thorough review of everything. So once you've completed the problems, I've also given you a video on how to do them. So let's go ahead and get started. So first one, they just want us to simplify, meaning combine like terms. So here I have 2x squared plus parentheses and then a whole bunch of other things. So this plus parentheses, since there's no number there, I can assume that that's 1. So 2x squared plus 4x minus 6x squared plus 9. And then this negative, I'm going to distribute like it was a -1 because it is. All right, so I got everybody lined up. Now I'm going to go ahead and I'm going to start combining like terms. So I'm looking to see what variable letters I have. I see I only have x's, so I'm going to look for the one with the biggest exponent, the x squareds. I'm going to put all those guys into a circle. And now I'm going to go ahead and combine them. 2 minus 6, negative 4x squared. Let's cross them all. Let's go ahead and do now the regular x's. I'm going to box those guys. 4 minus 6, negative 2x. Cross them off. Finally, my constants. 9 minus 3 plus 6. Here's my final answer. Super simple. All right, again, simplify. So 9x squared. And here, I have to distribute this in. I really don't have a choice. I can't multiply this to get rid of it because I don't have an equal sign. Okay? So that's going to be negative 2 times 3 divided by 3. So the 3's would cancel. Negative 2x. Okay? Plus, because negative times negative is positive. 2 times 7, 14 over 3. And then 5x squared. All right, these are some ugly numbers, but that's okay. We still got this. So I only see x's. I'm going to start with these x squared. That's the biggest exponent I can find. 14x squared. Got those. Oh, don't have to do anything to my x's. That's great. And nothing to do with my constants. So I'm all good. Next one. Find the perimeter, meaning I need to add them all up. So I could write them out. I could do a couple of different things. But I'm going to show you something that will make your life so much simpler. So when I was in school, they would just have us write it out like this. Now, I had you guys because I wanted you to understand what you were doing. But there's another way to do it that you can organize it in a chart to make it easier. So I'll write that in this purple color. And I look at everything I have, right? So I make a chart with how many ever spaces I need. So I have x's, I have constants, and that's it. So I'm going to put x's and C for constants. So I'm going to go ahead and write each one of these in the columns. So my 3x, my 5x, my 2x, okay? And now my constants, -4, +5. Now, I should have wrote it in a better place. Let me go ahead and move it. So now I can just go down the line and add up all the x's. 3 plus 5 plus 2, 10x. -4 plus 5 plus 1. So my perimeter equals 10x plus 1. Now, that's a trick to kind of help you organize it, so that way you're not having to do this like I normally would. Just another way to do things, okay? So, find the perimeter of the figure, perimeter. Now, the interesting thing about this is they neglected to put in the ones that are here. And because they are complete opposites of each other, and this is a rectangle, I can assume that those two sides are the same, that these two guys are the same. Now, lots of different ways to do this, okay? So I can make a chart, I can write it out. So if I wanted to write it out, I would say I have 2 of these and two of these, right? So 2 parentheses x plus 6 plus 2 parentheses 4x minus 5, right? And I can go ahead and simplify. Now, the other way to do that would be for me to say x's constants. So 4x minus 5, 4x minus 5, x plus 6, x plus 6. So 10x plus 2. Right? And we could have also distributed, not that way, combined like terms, and arrived at the same answer. All right, next one. Solve the equation. So remember, solving means x wants to be by itself. So first thing I want to do, of course, is distribute. Now I see that I have everybody combined that can be combined. I'm going to do exciting move, great divide. Let's move that 35. And great divide. And I find out that x is equal to 2. Okay. Next one. Solve the equation for x. Same thing. Let's go ahead and distribute. And let's go ahead and do exciting move, great divide. Whoever's not touching my x, I'm going to move first. And then great divide. I'm going to go ahead and divide by whatever this is equal to. Whatever the coefficient of x is. And I get an answer of x equals negative 14. Now, if you notice, I circled that negative. Sometimes the negative gets lost with the equal sign. Sometimes things happen and you misread it. I just like to circle them and make sure I show that. Alrighty. Next thing, find the perimeter of a figure. I'm going to go ahead and do the chart with this one again. I like the chart better. X's constants, 3x minus 1, 6x, 4x plus 3, 9 plus 4, 13x plus 2. My perimeter is equal to 13x plus 2. Next one, simplifying again. Okay, first let's distribute. So here I would have 6x minus 15 plus 6x minus 6. Let's go ahead and combine like terms. And I'm simplified. These are super easy. All right, let's keep going. Solve the equation for x. First, let's distribute. Actually, let me show you another interesting trick. So, I see that I could go ahead and distribute, do a whole bunch of stuff, right? But whenever I was looking at the numbers, I noticed something interesting about these guys. They're both negative and they're both multiples of 5. So, this negative 5 is technically multiplying. So let's divide by negative 5. They cancel here, and I get this. And boy, that looks a lot simpler than what they had me doing before, right? So remember what I said. So many different ways to do math. There's not always just one way. Some ways are easier, some ways are less time-consuming, but there's a lot of different ways to do it. So let's move our 7. Exciting move, great divide. X is equal to negative 2. All right, next one. Same thing. Look at that. Okay, they're both multiples of 2. They're not both negative, but that's okay. Okay. Exciting move. Great divide. X equals negative 14. All right, solve the equation for x. Okay, this is one of those crazy problems. Notice how they have a 4 in the denominator, 3, and a 3. Okay, so like I told you guys before, some people would say, oh, well, find the common multiple and all that other crazy stuff that takes 200 years to do, but we're not going to do that. Instead, I'm just going to figure out who are all my denominators. I see a 4 and a 3. I do not have to do both 3s, just one of them, because that would cancel them out. So I'm going to multiply everything I see times 3 times 4. And the reason for this is over here, my 4 will cancel. Over here, the 3 will cancel. And over here, the 3 will cancel. And so now I have 3 times x, 9x, 1 times 4, 4, 2 times 3 times 4, 24x, negative 2 times 4, negative 8. Okay, so I need to go ahead and get my x's together. I'm going to move this small one. Okay, so I got that. Now I'm going to go ahead and do exciting move. Great divide. Now, something about that fraction is just not sitting well with me. I see that they're both multiples of 3, so I'm just going to divide by 3. That looks much better. So my final answer would be x is equal to 4 over 5. Next one, finding the perimeter. I'm going to do a chart again. All these are x's, constants. I could do that. All right, so let's see. 1 plus 2 plus 6 plus 3. So that's going to be 12x. And then over here, 5 minus 17 plus 2 minus 10. My perimeter is equal to 12x minus 10. Alrighty, converting from standard to slope-intercept. Remembering that my standard form was ax plus by equals c. Slope-intercept is y equals mx plus b. Y is by itself, right? And remember what I told you, to go from standard form to slope-intercept form, exciting move, great divide, every single time. So first let's identify y is the guy that I need to get by itself. I'm going to do exciting move or whatever's not touching it on the same side. So I'm going to move this guy. Noticing that I'm writing the x first. Y equals mx plus b, and we can add and subtract in any order. The reason is for example, 2 plus 3 is the same thing as 3 plus 2, right? So I can add and subtract in any order I want to. I just like to write it like that to make it look easier. All right, great divide. Okay, now I got an equation of y equals 10 over 3x minus 5. Next one.
Wait a minute, Mr. Carmona. You're saying there's more problems than what we've already done? That's crazy. That's a billabong, wallaby, kangaroo situation there. Why, yes, there's more. There's always more.
And again, I'm going to do the same exact thing. They want me to take it from standard form, ax plus by equals c, all the way over to y equals mx plus b. Noticing that my y is by itself, it's positive, and it's 1y. So I'm going to highlight that y, everything that's on the same side, but that is not attached to it, I'm going to move, exciting move, noticing that I'm writing my x in the front. Now I'm going to do my great divide. Divide by whatever is attached to my y. And I absolutely must divide every single thing I see. And I end up with an answer of y equals 3/4 x minus 5. Next one. Again, exciting move, great divide. So I'm focusing on my y. Let's move that 3x over. Now I'm going to do, that was my exciting move. Let's do my great divide. Whatever is attached to my y, I'm going to go ahead and divide everybody by. And I have absolutely no idea what that is. 20, 1, 2, 3, 23. And I get my answer. Right? So it's the same thing over and over. Exciting move, great divide. Exciting move, great divide. Again, so exciting move. Great divide. Every single one of these problems that they're asking you to do this with, exact same process every single time. Again, exciting move, great divide. Now, if you notice, I just want to make note of this since we're at the beginning of the year. I always like to write my fractions out separately, okay? The reason is that it's just easier for me to read, and it's going to be easier whenever we're trying to graph these. You can also write this as or, right? So there's a lot of different ways to write it. I just write it like that because it's easier to read. All right, same thing. Exciting move. Great divide. Okay, next one. Okay, here they're asking me to solve the equation for b. So I need to get an answer, remembering, because solve means b equals everybody else. So even if they gave me something like, they could say solve for y, and that would mean they want me to move everybody else over to the other side, right? It doesn't matter whether or not there's other variables or anything else. Typically, when we hear solve, we think x is equal to a number, but sometimes it can look a little bit different. So just something to be aware of. All right, let's go ahead and get this one going. So first, let's go ahead and distribute, get rid of those parentheses, because I don't like dealing with them. Okay, now I'm going to go ahead and combine like terms on each side. And over here, I'm going to do the same thing. Okay. So now I'm going to go ahead and I'm going to say, all right, which one of these is smaller? Well, I see a 42 over here and a 40 there. So in my mind, I would have thought that that 40 was going to be smaller, but these are negative numbers. So the more negative is smaller. So that's this guy over here. Let's move him. And the great thing about doing this is now we're back into the positives. Okay, now we're just left with exciting move, great divide. Great divide. And I get an answer of b equals a negative 22. Okay, all I'm doing is same exact process over and over. That's what a lot of math is. Same exact process. All you have to do is just understand what the process is, okay? All right, so let's take a look at this one. Let's go ahead and Distribute to get rid of these parentheses. Same thing here. All right, let's combine like terms. Everybody over here is fine. Everybody over here, well, we got a lot of x's everywhere. Okay, now let's go ahead and get all of our x's together because they're all over the place. I see that this one's smaller, so let's move him. Okay, exciting move, great divide. And no divide to do, x is equal to 10. All right, next one. Again, first let's go ahead and distribute on both sides. Okay, I got those. Let's go ahead and combine any like terms. Okay. All right, let's start grouping all of our variables together. I want them on one side. I see a negative 12 over here. That's the smaller one, so I'm going to go ahead and move it over. Okay. Now I'm going to go ahead and do my exciting move, great divide. Okay. So that was my exciting move. Let's do great divide. N equals 7. All right, good job. Let's keep going. Okay, next one. So again, doesn't matter what the variable is. Same exact process. People just like to change whatever letter they're choosing just to confuse you. No different. Go ahead and distribute. Okay, now let's go ahead and combine like terms. Okay, now let's go ahead and start getting our variables together. I see a 16 and an 18. I'll move the smaller guy because it's easier. Now I'm going to go ahead and move my 6 over, Y, exciting move. And great divide. Okay. All right. So let's take a look at this one now. All right. Same situation here. Let's go ahead and first start by getting rid of these parentheses. We don't like parentheses. So 20r minus 14 minus 2 minus 20r equals negative r plus 2r. Okay, they're doing a lot here. They have these r's all over the place trying to get us confused. So let's go ahead and start kind of pulling this apart. So first thing, let's look over here on the left side. I see an r here. I see an r here. They are a zero pair. That's my fancy word for cancels out. Okay. And I see numbers that are separated. I'll put those together. Over here, I see r's all over the place. And look at that. All I had to do was combine like terms. That was easy. Okay, next one. All right, remembering that if I have a negative on the outside and no number, it's like multiplying by negative 1. So, plus 5 plus x equals negative 18x plus 9 minus 1. Okay, let's combine like terms over here on the left side. Let's combine like terms over here on the right side. Okay, now let's go ahead and take a look at all of our variables. They're all over the place, right? We got some on the right, some on the left. That -6 is smaller, so I'm going to move him because I don't want to start creating, oh, excuse me. Actually, no, I was wrong. The -18 is smaller. Let's move him. Okay, so over here I have 12x plus 5 equals 8. And guess what? Same thing again. Exciting move, great divide. So let's move the 5. Divide by 12. And something looks a little off about that fraction. I don't like how it looks. They both can't be divided by 2. They can both be divided by 3. So x is equal to 1/4. Same thing as 0.25. Okay, next one. Here we're dealing with the inequalities. Remembering our 2 rules for dealing with inequalities. It flips at multiplying or dividing by a negative number on both sides. And my x's always move to the left. Okay, let's go ahead and distribute. Okay, did I multiply or divide by a negative number? No, so it's going to stay the same. All right, nothing to combine over here on the left, so I'm just going to rewrite that. And I do have stuff to combine over here at the right. So it'd be 20h plus 5. Did I multiply or divide by a negative number on both sides? No, I did not. So I'm going to go ahead and leave my symbol the same, noticing that I rewrote it with the h in the front. I like to leave it in standard format so I don't start getting confused, especially whenever you have equations that have all these exponents and different variables. I like to have it lined up so it's easier to tell. All right, let's go ahead and move my h's all over to the left side, right? Doesn't matter who's bigger or smaller for these guys. And here, I did not multiply or divide by a negative number. Symbol stays the same. Exciting move. Did not multiply or divide by a negative number. Great divide. Did I multiply or divide by a negative number? No. So h is less than 1. All right, same thing here. Let's go ahead and first get rid of these parentheses. I don't like dealing with those. Okay, did I multiply or divide by a negative number on both sides? No, I did not. So my symbol's going to stay the same. Let's go ahead and first combine like terms over here on the left side. Noticing again that I'm trying to get it into that standard format. Nothing to bother with over here on the right side. And I did not multiply or divide by a negative number on both sides. So my symbol is going to stay the same. All right, let's go ahead and get all of my variables over to one side. Doesn't matter who's bigger or smaller. I did not multiply or divide by a negative number on both sides. Therefore, my symbol stays the same. Now I'm going to do exciting move. And I did not multiply or divide by a negative number on both sides. My symbol stays the same. Great divide. And here I did multiply or divide by a negative number. My symbol's going to flip. So P is less than -2. All right, let's keep it going. We're almost done. So first thing I'm going to do is I'm going to go ahead and distribute. Let's get rid of those parentheses. They're there just to bother me. Okay. I asked myself, did I multiply or divide on both sides by a negative number? Nope. Symbol stays the same. Okay, let's look over here at the left. Nothing to combine. I'm going to copy it over. Let's look at the right. I got x's all over the place. So I'm going to go ahead and combine those. Did I multiply or divide by a negative number on both sides? Nope, did not. Symbol's going to stay the same. Now I'm going to go ahead And I'm going to get my x's all over to the left. So minus 6x on both sides to get that moved. Oh, and look at that. This is going to be an easy one. I'm not going to have to divide by anything. So did I multiply divide by a negative number on both sides? Nope. Symbol stays the same. I'm going to do my exciting move. And I end up with a final answer of x is greater than 27. How did I know there wasn't going to be a great divide? Well, there's a 1 here. We don't have to divide by that 1. It'll stay the same. Okay, over here. So now there's a couple of ways we could go about doing this. Because remember, this functions similarly to an equal symbol. So that means that I can do stuff like multiply, divide, things like that to both sides to kind of get rid of the fractions. So what I could do, I could multiply everything I see by 3 and simplify that way. Or I can take a look at what, so hold on, let me go through that very quickly. So I could go ahead and just multiply everything that's on the outside by 3, and that way I could get rid of this fraction. Or I can go ahead and just distribute, right? So I would say 1/3 times 9, that's 3 with the negative, -3, and the same thing with the 18. Now, when would I do each one of those? Well, here's the thing. If inside of the parentheses is going to be evenly divisible by that 3 or whatever fraction you're multiplying by is going to make whole numbers, I go ahead and distribute. But if it's going to start making fractions, I try and get rid of the fractions so I'm not having all these crazy numbers. Okay? So for this one, I would go ahead and just distribute. Because 9 and 18 are both multiples of 3. So here I have 3x minus 9 minus 5x minus 3x minus 6. Okay, got that. Did I multiply divide by a negative number on both sides? No, I did not. My symbol's going to stay the same. Let's go ahead and start combining like terms. So first I'm going to look over here on the left. I see I have x's all over the place. That 9 doesn't change. Nothing over here changes. I ask myself again, did I multiply or divide by a negative number on both sides? No, I did not. So my symbol stays the same. Now I'm going to go ahead and get all my x's over to the left. Remember, because we don't want to struggle having to read this. So plus 3x plus 3x. So x minus 9 and has some relationships to -6. Did I multiply or divide by a negative number on both sides? No. Symbol stays the same. Exciting move. And look at that. They made it easy again. No great divide. So did I multiply or divide by a negative number on both sides? Nope. Symbol stays the same. All right. Last two. Okay. So solve for x. First, I'm going to go ahead and distribute. Noticing that this one has the extra line, meaning it's also equal to. Okay, so negative 8x minus 16 minus 9x, negative 2x plus 14. Did I multiply or divide by a negative number on both sides? No, symbol stays the same. Okay, let's start combining like terms over here on the left. I see these x's all over the place. Noticing again, I'm writing this in standard form just to help me stay organized. All right. Did I multiply or divide by a negative number on both sides? No. Symbol stays the same. All right. Let's go ahead and get these x's together. So I'm going to move this guy, remembering we always want to move towards the left when we're dealing with inequalities, just to make our life easier. Everything else is going to remain the same. Did I multiply or divide by a negative number on both sides? Nope. Symbol stays the same. Okay. Now I'm going to do exciting move, great divide. So I'm going to go ahead and get rid of the 16 because it is not attached to my x. Okay, so now that I have that, I ask myself, hey, did you multiply or divide by a negative number on both sides? No, I did not. Symbol stays the same. Now I'm going to go ahead and do my great divide. And I say x has some relationship to -2. Did I multiply or divide by a negative number on both sides? Yes. My symbol is going to flip directions, so now x is smaller than or equal to -2. Also said the fancy way, x is less than or equal to -2. All right, excellent. So let's go ahead and start by distributing. I look here. I see a 2 at the bottom, which means I need to be able to evenly divide all those numbers by 2. Everything in there is divisible by 2, so I'm fine with distributing that one instead of multiplying to get rid of it. Let's go ahead and finish this up. Okay. Did I multiply or divide by a negative number on both sides? No, I didn't. Symbol stays the same. All right, let's see if I have any like terms to combine. I do. My 48 is not going to change. Okay, so now I can go ahead, copy over here. Nothing else changes. Did I multiply or divide by a negative number? No. So my symbol stays the same. Okay, let's get all these x's together. Remember, we're always moving everybody to the left. Okay. All right. So now I'm going to do exciting move, great divide. Again, I did not change the direction of my symbol because I did not multiply or divide by a negative number. Let's go ahead and do exciting move. Now, I take a look at this and I say, wait a minute here. This looks cray-cray. 10 minus 10. So if I have $10 and I spend $10, I have nothing, right? I have zero. Zero is a number for nothing. Do not get confused. Don't think that zero is not a number. It is. A lot of people make that mistake, okay? That multiply or divide by a negative number on both sides. Nope, symbol stays the same, okay? So now I'm going to go ahead and divide by 41, okay? If I do that, I get x has some relationship to 0. Why? 0 divided by 100 is 0. 0 divided by a million is 0. 0 divided by anything besides another 0 is always 0. Do I multiply or divide by a negative number? Nope. That means that my answer remains the same. Thanks so much for paying attention. Make sure you're prepared for our checkpoint.